Hey, today I want to talk about review for antiderivatives, integrals, and the volumes, section 3.9, the chapter 4 and chapter 5. Here, you need to know table of antiderivatives formulas. Assume that capital F prime of x is f of x. The capital G prime of x equals little g of x. The k is a constant. So what is it like antiderivatives? So we have these things. The k times little f of x. The antiderivative is k times capital F of x. The f of x plus or minus g of x. Antiderivative is the capital F of x plus or minus capital G of x. So k is constant. So antiderivative is kx. The x to the power n is not equal to 1. The antiderivative is x to the n plus 1 over n plus 1. Oh, this is like a typo. X is not equal to minus 1. This is a typo here. This one, not this one. X is not equal to minus 1. X is not equal to minus 1. So x to the n plus 1 over n plus 1. Sine of x. Antiderivative is negative cosine of x. The cosine of x antiderivative is positive sine. Secant square of x, the tangent x. The cosecant square of x antiderivative is negative cotangent of x. The secant x times tan x, the antiderivative is the secant x. The cosecant x times cotangent x, the antiderivative is negative cosecant x. So note, an antiderivative of f prime of x is f of x. The antiderivative of the second derivative is the first derivative. The s of t is a position function. The v of t is velocity. A of t is acceleration. What's it like v of t? The v of t is s prime of t. And a of t is v prime of t. So what's that? This is also the second derivative of a position function s of t. The antiderivative of a of t is velocity. The antiderivative of velocity is position. So we have these kind of things. You need to memorize these whole kind of things. So we solve this problem together. The f prime of x is secant square of x plus x squared plus 3x minus 2 over square root of x and f of 0 equals 5. So how can you solve? The first, you have to split this one. Here, first one is secant square of x the same. So we can change this one to the x to the 1/2 and split x square of x to the 1/2, the 3x over x to the 1/2, 2 over x to the 1/2. We have this form to split. The next is simplify. Here, the 2 minus 1 over 2 is 3 over 2. This is power 1. Power 1 minus 1 over 2 is 1 over 2. So the 2 times 1 over x to the 1/2, you can change negative 1/2. The next, find antiderivative. So what is antiderivative of secant square of x? So do you know? So what is antiderivative of secant square? Do you know? Okay, good. So right. The other part is you can use a power rule. So the 1 over 3 over 2 plus 1, x to the 3 over 2 plus 1. So here, keep 3. Find antiderivative of x to the 1/2, the 1/2 plus 1, x to the 1/2 plus 1. You have to keep -2, and antiderivative of x to the minus 1/2 is 1/-1/2 plus 1, x to the minus 1/2 plus 1 plus c. To simplify, the tangent x plus, the simplify this one. So this one is exactly same to 1/5/2. We have to flip 2/5. The 3/2 plus 1 is 5/2. We can keep 3. 1/1/2 plus 1 is the 1/3/2. The flip 2/3. This -2 is here. This one is the -1/2 plus 1 is 1/2. 1/1/2 is 2. So plus c. So next, change back to square root form. Here, x to the 5/2 is the square root of x to the 5. The 3 is crossed out, only 2. X to the 3/2 is like square root of x cubed. The 2 times 2 is here 4. X to the 1/2 is square root of x. So this is the whole idea for solving this problem. So next, you need to find c by using f of 0 equals 5. You can plug 0 into here. Here. So what happens? Like this. So this is 0. This is 0. This is 0. What is tangent of 0? So do you know what is tangent of 0? Tangent of 0 is, 0. The final answer is c equals 5. So you can plug this 5 into here. The final answer is tangent x plus 2/5 square root of x to the 5 plus 2 times square root of x cubed minus 4 square root of x plus 5. That's it. This is answer. The next problem, a particle moves in a straight line and has acceleration given by a of t equals 60 plus 4. This is initial velocity. So this is typo again. So its initial velocity is v of 0 equals -3 centimeters per second. Its initial displacement is s of 0 equals 5 centimeters. Find its position function. The next, you can find v of t. How can you find? The antiderivative of 60 plus 4. So we have this one. You can keep 6. The antiderivative of t is t square of 2. The 4, antiderivative of 4 is 4t plus c. This is most general antiderivative. Simplify, only 3. The like 2 is crossed out. The 3t square plus 4t plus c. The next, how can you find c? You can use initial velocity. Use it. You can plug 0 into here. The 3 times 0 square plus 4 times 0 plus c equals -3. So this is 0. This is 0. What is the answer? C equals -3. The plug the -3 into here. The v of t equals 3t square plus 4t minus 3. The next, find s of t. S of t is the antiderivative of velocity. So we have this one. You have to keep 3. So antiderivative of t squared is t cube over 3. You can keep 4. The antiderivative of 4 is t squared over 2. The antiderivative of -3 is -3t plus constant d. How can you find d? So simplify here. So simplify, cross out. So we have this result. Next, how can you find d? So we use initial displacement. Initial displacement. S of 0 equals 5. So you plug 0 into here. 0, 0, 0. So we have it equal to 5. So what's that? This is 0, this is 0, 0. We have t equals 5. You can plug t equals 5 into S of t. The final answer is t cubed plus 2t squared negative 3t plus 5. That's it. This is the idea for finding the position function from the acceleration. Was like a graph of function f is given, make a rough sketch of an antiderivative capital F, given that capital F of 0 equals 2. So we know this one. Capital F prime of x equals f of x. So we use increasing, decreasing test, concavity test, first derivative test. The x is between 0 and 1 here. What's that? So this is capital F, the little f of x is exactly capital F prime of x. So x is between 0 and 1. What happens capital F of x here? So we have this portion. The capital F prime of x is below x-axis negative, is right? So we know here f prime of x is like less than 0. So what does it mean? The function f is increasing. So we know this one, the increasing. So we have f of x is increasing. So like this. So one more. Was it like f prime of x? F prime of x is increasing. So here, f prime of x is increasing. So what does it mean? So do you know this one? The graph of f is concave up. Concave up. So we have concave up. So we have this result. So like this. X is between 1 and 2. The 1 and 2, the here, the 1 and 2. The, what's that? The capital F of x is increasing or decreasing in interval 1 and 2. So what do you think? Yep, this is increasing because we have positive capital F prime like increasing. So one more, F prime of x is increasing. The capital F prime of x is increasing. The graph of capital F is concave up. So we have increasing concave up. The 2 to 3, the similar. This is a positive. So graph is increasing. So we have increasing. One more. Was it like capital F prime of x decreasing? Capital F prime is decreasing. What's that? The graph of f is concave down. So we have concave down. The 3 to 4 here below x-axis. So decreasing. So this is capital F prime is decreasing. So capital F is concave down. For greater than 4 here, we have below x-axis negative, graph is decreasing. Was like capital F prime of x increasing. So concave up. So we have it. So you can draw exact graph. How can you draw the graph? You can use this idea. So here, this one, here, f of 0 equals 2. This is the starting point. We have 2. So here, the 0 and 1, 0 and 2, 3, 4, 5, and so on. So like this. The 0 and 1 graph is decreasing concave up. So we have decreasing concave up from here. Decreasing concave up. So like this. The 1 to 2 increasing concave up. We have here local minimum increasing concave up. 2. 2 to 3, increasing, concave down, concavely changed, increasing, concave down, so like this. The 3 to 4, decreasing, concave down. We have decreasing, concave down, so like this. Last one, decreasing, concave up. Graph is decreasing, concave up, so like this. So we have this kind of things. We have it like this. So we have it. Okay, this is a whole idea. The next one. The integral from a to b f of x dx. So we need to know the exact limit definition. Limit n approach infinity, summation from I equal to 1 to n, f of xi star times delta x. The limit summation I equal to 1 to n f of xi, or summation from I equal to 1 to n f of xi minus 1. The another one is xi minus 1 plus xi over 2. So here, this is was it like xi star. So we have this position. We have sub-intervals here. xi minus 1, the xi. What's the choice of xi star? So we have infinity many choices. The first choice is right-hand point, this one. Or xi star is left-hand point, xi minus 1, or midpoint, xi minus 1 plus xi over 2. We have three possibilities in this section. What's like delta x? Delta x is b minus a over n. xi is a plus I times delta x. So xi is right-hand point. xi minus 1 is left-hand point. xi minus 1 plus xi over 2 is midpoint. So what's like a Riemann sum? The Riemann sum is only this part. It's called Riemann sum. This portion, this we call Riemann sum. This one, so like this. This is Riemann sum. This one. Summation I equal to 1 to n f of xi star times delta x. So next one. Was it like area of R1 equals A1, area of R2 equals A2, area of R3 equals A3? Was it integral from A to B f of x dx? Exactly. A1 minus A2 plus A3. So we call net area here. Above x-axis positive, below x-axis negative, above x-axis positive. This is the reason. Positive, negative, positive. We call net area. This is geometric meaning. So this equation, f of x equals 2x squared plus 1. The 0, 2 is given. Find the Riemann sum with the four sub-intervals using right-hand point, using left-hand point here. So what's that? So you need to solve next one. What's it like a Riemann sum? Do you remember? Riemann sum? Summation I equal to 1 to n. F of xi star times delta x. Was it like right-hand point? In this case, xi star is xi. Was it like left-hand point? The left-hand point is xi star is xi minus 1. So let me see. You can decide these whole kind of things. So remember, was it like delta x? So we have the delta x is p minus a over n. Was it like xi? Xi is the a plus I times delta x. You need to find these kind of things. First, you can decide n. What is n? What's n of this problem? Yes, we have 4 sub-intervals, exactly 4. What is a? So what is a in this problem? A is here. given interval, left-hand point is A. This is 0. What's it like B? The B equals right-hand point 2. This is like B. So you can find these things. So what's that? So this one is exactly from here. Delta x equals, what's B? B equals 2. A is 0, n equals 4. We have 2 minus 0 over 4. Answer is 1 over 2. What's like xi? We have a plus I times delta x. A is 0 plus I times delta x is 1 over 2. So we have 1 over 2i. This is xi. So what is it like right endpoint? You can plug xi into here. So we have this one. The answer of A is summation I equal to 1 to 4 f of xi times delta x. You have to expand. You plug 1 f of x1 plus f of x2 plus f of x3 plus f of x4 times delta x. Delta x is, we have it here, 1 over 2. This equation. What's like answer of B? Answer of B is summation I equal to 1 to 4 f of xi minus 1 times delta x. The same. You plug 1 into I. The first term is f of x 0 plus f of x1 plus f of x2 plus f of x3 times delta x 1 over 2. We have these two kind of things. You can decide, was it like x1, was it like x2, x3, x4? Here, xi is 1 over 2i. You plug 1 into I. So we have it, this one, f of 1 over 2 plus f of 1 over 2 times 2. 1 over 2 times 2 is 1. Plus plug 3. We have plug 3 into I. 1 over 2 times 3 is 3 over 2. Plus you plug 4 into I. 1 over 2 times 4 is f over 2 times 1 half. So this is plug 0 into I. 1 over 2 times 0 is f of 0 plus f of 1 half plus f of 1 plus f of 3 over 2 times 1 half. This is like a whole idea. So you need to know f of 0, f of 1 half, something like that. How can you find this kind of things? You plug this number into here. Plug into here to find answer. So what's that? So I can write the more things here, like this. So we already have it. You can find f of x0. F of x0 is f of 0. You plug 0 into here. 2 times 0 square plus 1 is 1. F of x1 is the 2 times plug here, same. 1 over 2 square plus 1. 1 over 2 square is 1 over 4. 1 over 4 times 2 is 1 over 2. 1 over 2 plus 1 is 3 over 2. F of x2 is f of 1. The 2 times 1 square plus 1 is 3. F of x3 is f of 3 over 2. You plug 3 over 2 into here. The 2 times 3 over 2 square plus 1. So we have 11 over 2. F of x4. This is typo, sorry. This is 2. So this is 2, change it. So 2 times 2 square plus 1 is like 9. So we have these kind of things. The next, the right-hand point is this one. You can plug these numbers. F of x1 f of x2, f of x3, f of x4. So we have like this, and simplify. We have 19 over 2, b, summation n equal to 1 to 4, f of x I minus 1 times delta x is here. So exactly previous one, this one, this one, this one, and this one. So we have like this. The same. The simplify, we have 11 over 2. So this is whole idea for solving this problem. The next tip. Find an expression for the area under the graph of f of x equals x squared negative 6x, x is between 1 and 4, as a limit by using right hand point. So what's that? So how can you express this one? You can use like this one. Limit and approaches infinity. So what's that? Summation I equal to 1 to n. We can use right in the point. Xi star is xi. F of xi times delta x. This one. So how can you find the delta x? We can use formula. Delta x equals b minus a over n. So what is b? What is b? Yep, it's good. Right in the point 4. What is a? What is a? Yes, the left-hand point 1. So 4 minus 1 over n is 3 over n. You can find xi. Xi is a plus I times delta x. So what is a is 1. I times delta x is here, 3 over n. So we have 1 plus 3 over ni. So what is the answer? The final answer is next one. Limit n approaches infinity, summation I equal to 1 to n. So we have f of xi. You can plug xi. 1 plus 3 over ni into this x. So we have 1 plus 3 over ni squared, negative 6 times 1 plus 3 over ni times delta x. Delta x is here, 3 over n. That's it. This is answer. So this is the final answer. The next one, we are going backward. The limit form is given. You can change it to the definite integral. That's right. So this definite integral is exactly same to the like this. So limit and approaches infinity. So we have summation I equal to 1 to n f of xi times delta x, like this one. You can compare this one. Given problem, limit summation minus 1 plus 5 ni q plus 3 times minus 1 plus 5 ni times 5 n with this limit definition. You can decide delta x. What is delta x? What's delta x? You can compare this one. You can compare with this one and this one. What is delta x? Delta x is here. So delta x is exactly 5 over n. This is rule. We have 5 over n. What's it like the definition of delta x? Delta x is p minus a over n equals 5 over n. So what happens? We have numerator p minus a equals 5. So we have it. Next, what is xi? Here, xi is this one. -1 plus 5 ni. -1 plus 5 over ni. This is xi. -1 plus 5 over ni. What's it like the definition of xi? Definition of xi is a plus I times delta x equals -1 plus 5 over ni, right? So what's that? This a is exactly same to -1. From here, we know a equals -1. You plug a equals -1 into here. So we have p minus -1 equals 5. Exactly. p plus 1 equals 5. Subtract 1 from both sides. p equals 4. So we have it. Is right? The next, what is log of f of xi? Log of f of xi, this is a whole thing, except delta x, this whole thing, this one. So we have f of xi is exactly same to -1 plus 5 over ni cube plus 2 times -1 plus 5 over ni. So what is -1 plus 5 ni? Exactly xi. We can replace by xi cube plus 2 times xi. So we have this result. F of xi equals xi cube plus 2xi is right here. This one equals this one. So what is f of x? So could you write your answer? So if you know this answer, could you write what is f of x? So f of xi is xi cube plus 2xi. What is f of x? So f of x is here. Only replace xi by x, xi by x. So we have x cube plus 2x. So we have it. So what is definite integral? Integral from a to b f of x dx? Integral. Was it like a? So we have it. This one, -1. Was it like a b? Here, 4. What is f of x? F of x is x cubed plus 2x. That's it. This is the final answer. Like this. The next one. So evaluate the integral -6 to 6, the square root of 36 minus x squared plus absolute value of x minus 2 dx. How can you calculate this kind of problem? So do you know how can you calculate? So integral -6 to 6, the square root of 36 minus x squared plus absolute value of x minus 2 dx. Do you know how can you solve this problem? So we cannot use a formula. We cannot use integration formula. So what's like a best way? We can use, oh yeah, the antiderivative. So here, what is the antiderivative of this one? The square root of 36 minus x squared. So we don't have it. So we don't have it, this one. Was it like an antiderivative of absolute value x minus 2? Not easy. So in this case, how can you solve? We have to use geometric method. Was it like a geometric method? Here. So geometric method is like this. This is like a graph f of x from A to B. You need to find this area, A1, this area, A2, this area, A3. Was it like integral f of x dx? We can use net area. Above x-axis A1, below x-axis negative A2, above x-axis plus A3. This is whole idea. We call net area. You can use net area. So first one, do you know graph of this one? So first, you can distribute is better. Distribute inequal, like this. Distribute inequal. So what's that? This is same to inequal negative 6 to 6. The square root of 36 minus x squared dx plus inequal negative 6 to 6. Absolute value of x minus 2 dx. You can split two integrals. So do you know what is the graph of square root of 36 minus x squared? Do you know what is the graph? The graph is like this. So we don't know exact graph, so you can use this idea. The y equals this function. The square root of 36 minus x squared. The next square both sides. Y equals square root of 36 minus x squared, square both sides. So we have the y squared equals 36 minus x squared. You can add the x squared to the both sides. So we have x squared plus y squared equals 36. 36 is 6 squared. So what's that? This is circle. The radius is 6. Center is 0, 0. So we have only circle. This one, so let me see. What's the original problem? Original problem is y equals the square root of 36 minus x squared. This is always positive one. We don't have a negative sign in front of square root, so you don't need bottom one. Only choose top one, top curve. So what's it like a domain? The negative 6 to 6, exactly this area. This area. What's it like this area? So circle. What's it like area of a circle? Area of a circle is pi times r squared. This is half divided by 2. So we have 2 is crossed out. So 18 pi. The next one. So this is same to what? First one is 18 pi plus. The second one. What's the graph of x minus 2? The y equals absolute value of x minus 2. So graph is like this. This is, vertex is 2 here. So we have from negative 6 to 6. The 6, you can find this area. You can find function value. What's the function value? You plug negative 6 into here. The absolute value of negative 6 minus 2 is absolute value of minus 8. Absolute value of minus 8 is positive 8. So we have it. So here, you plug 6 into x. Absolute value of 6 minus 2 is 4. We have 4. So what is the area of this triangle? Here, The width is A. The width is A. Height is A. So area of this triangle is 1 over 2 times A times A. Exactly. So 4 times 3 is 32. This is area. What do you like this area? The width is 6 minus 2. We have 4. The length is 4. So we have 1 over 2 times 4 times 4. 2 is crossed out. So exactly 2 times 8. So 2 times 8 is 16. So what is this area? This area is sum of two areas, 32 plus 16. So 32 plus 16 is 48. So we have 48. Do we have it? This is the idea for solving this problem. So like this. Oh, the 48, not 40, sorry, the 40. So this is 32 plus 8. Sorry about that. The 32 plus 8 is just 40, not 48. The next one, fundamental theorem of calculus, part 1. Assume that function f is continuous on interval ab. Was it like f of x? Capital F of x is integral from a to x, f of t dt. So was it capital F prime of x? Integral from a to x, f of t dt prime is, so exactly f of x. So this equation, so we have integral from 1 to x. Here, sine to the power 4 t, dt prime. What is the answer? So what is the answer? By using the fundamental theorem of calculus, part 1. So what is the answer? Answer is, what's that? Here. Integral from a to x, f of t dt is same function, only replace t by x. This is the whole idea. Only plug x into here. Final answer is sine to the power 4x. That's it. So we call the fundamental theorem of calculus, part 1. So we have applications. So what's that? Here we have it. You can plug g of x into t times upper limit prime. Here, similar. You can plug h of x into t, f of h of x times lower limit prime. You have to keep. You have a lower limit, always take minus sign. So what's that? This is difference. You can plug upper limit into here times upper limit prime minus. You plug h of x into t, f of h of x times lower limit prime. So we have 3 applications like this. So this is like a function. You can find the derivative. The first one, what is capital F of x prime? How can you do that? The same. You plug root x into t. So we have sine of 5 plus root x square times upper limit prime. So like this. So we have sine 5 plus the square root of x square is only x times what is square root of x prime. You can change x to the 1 over 2 prime. This is power rule. 1 over 2 times x to the minus 1/2. You can change it to the positive exponent. X to the minus 1/2 is 1 over x to the 1/2. You can change it back to radical form, 1 over 2 root x. So we have 1 over 2 root x. The combine, what's that? Sine of 5 plus x over 2 times square root of x. This is answer. So like this. The g of x prime, how can you do that? Similar. You plug tangent x into t. So we have sine of 5 plus tangent of x squared times lower limit prime. The one more. We have a lower limit. Take what? Negative sign. So like this. And calculate. Negative sine of 5 plus tangent square of x times, what is tangent prime? Do you know what is tangent prime? Yes, secant square of x. So that's it. This is final answer of this question. So we have it like this. Next, the fundamental theorem of calculus part 2. This is very useful. So assume that the little f is continuous on closed interval a, b. Was like integral from a to b f of x dx. The capital F of x from a to b. The capital F of b minus capital F of a. You can find the antiderivative. This is idea. The where capital F is any antiderivative of f. So what does it mean? Capital F prime is little f. Table of indefinite integral. You need to know this kind of things. Integral kf of x dx, take out k. K times integral f of x. Integral f of x plus g of x dx is, so you can distribute integral f of x dx plus integral g of x dx. Was it like integral k dx? Integral k dx is exactly kx plus c. So what does it mean? We have one example is integral 5 dx is 5x plus c. What is integral dx? Do you know what's integral dx? What is the answer? So what is integral dx? So do you have any idea what is integral dx? So integral dx is exactly 1 times dx. So integral 1 is 1 times x is x plus c. So we have this answer. So integral x to the n is 1 over n plus 1, x to the n plus 1, same. This is not n equal to 1. Sorry about that. N equal to minus 1. This is typo. N equal to minus 1. Integral sine x dx is negative cosine x plus c. Integral cosine x dx is positive sine x plus c. Integral secant square of x dx is tangent x plus c. Integral cosecant square of x dx is negative cotangent x plus c. Integral secant x tan x dx is secant x plus c. Integral cosecant x cotangent x dx is negative cosecant x plus c. So you need to know u substitution. U equal to g of x, the differential form du equals g prime of x dx. How can you solve integral f of g of x times g prime of x? Here, the inner function g of x is like u, plug into here. Exactly, integral f of u. G prime of x dx is du, like this. The next find antiderivative. The next change back. The u is g of x. This is whole idea, like this. Was it like definite integral? This is very similar. The inside one is same, f of u du, the same. Was it like a difference? You can plug a into here. We have g of a. You can change the lower limit. You plug b into here, g of b. Find antiderivative from g of a to g of b. You can plug g of b and the g of a, f of g of b minus f of g of a. This is whole idea for solving this problem, like this. So we have a lot of examples by using integration formulas or u substitution. So first problem, here. How can you solve? In this case, do you know how can you solve? So in this case, split root 5 and x is better. Split like this. The square root of 5 times root x. You can take out square root of 5. This is constant. Just only what? The take out. The root x is x to 1/2. You can use power rule. So the integral x to 1/2 is 1 over 2 plus 1, x to the 1 over 2 plus 1. This is same to like this, right? Because here, so we have root 5 times, this one is 1 over 3 over 2. 1 over 3 over 2 is 2/3. We have 2/3 x to the 3 over 2 from 1 to 9. So we can change it to root 5 over 3 x to the 3 over 2 from 1 to 9. So like this. Next, you plug 9 into here. You can keep coefficient 2 root 5 over 3 times 9 to the 3 over 2 minus 1 to 3 over 2. What is 9 to the 3 over 2? 9 to the 3 over 2 is, the 9 is 3 square to the 3 over 2. 2 is crossed out, just 3 cube. The 3 cube is 27. So we have 2 root 5 over 3. The 27 minus 1 to the power is always 1. So we have 2 root 5 over 3 times 26. So you cannot cross out. The 2 times 26 is 52. Root 5 over 3. This is the answer. So second problem. This is a product of two functions. Was like the best way? Don't use the u substitution here. So change root x to the x to the 1/2. So was 2 of x, 2 times x to minus 1. Next, distribute x to 1/2. So we have it. So this is 1. The 1 over 2 plus 1 is 3 over 2. The 1 over 2 minus 1 is negative 1/2. The next, find antiderivative. Sum the 1 over 3 over 2 plus 1, x to the 3 over 2 plus 1, 2 times 1 over minus 1 over 2 plus 1, x to the minus 1 over 2 plus 1 from 1 to 4. So how can you solve? So this is 1 over 3 over 2 plus 1 is 5 over 2. Just to flip, 2 over 5. X to the 5 over 2 plus 2 times. So minus 1 over 2 plus 1 is 1 over 2. 1 over 1 over 2 is 2. X to the 1/2 from 1 to 4. So you can plug 4 into x. We have 2 over 5 times 4 to the 5 over 2 plus 2 times 2 is 4. The 4 times plug 4 to the 1/2 minus plug 1. The 2 over 5 times 1 to the 5 over 2 plus 4 times 1 to the 1 over 2. To simplify, was it like a 4 to the 5 over 2? The 4 to the 5 over 2 is 4 is 2 square to the 5 over 2. 2 is crossed out, 2 to the 5. 2 to the 5 is 32. We have 32. So this is 2 over 5 times 32 plus the 4 to the 1/2 is root 4 is 2. 2 times 4 is 8. So this is distribute negative. The 1 to the 5, 2 is 1. 1 to the 1/2 is also 1. We have negative 2 over 5, negative 4. So what's that? This is 64. Minus 2 is 62. We have 62 over 5. The 8 minus 4 is plus 4. You can change it to the fraction with common denominator 5. 4 is 20 over 4. You add it, 24 over 5. 20 over 5. So 62 plus 20 is 82 over 5. That's it. This is the final answer. So like this. The next tip. How can you solve this problem? We can use the graph a little bit. The integral absolute value sign of x. First, you can use the graph of absolute value sign of x. The first, y equals the sign of x. So we have it, is right? This is exactly from 0 to 3 pi. Here, this is 0. This is pi. This is 2 pi. This is 3 pi. We have it. What is absolute value? This one. So not difficult. So take absolute value. You can keep positive one. You have to keep positive one. The negative one is going to up. We have, yes, negative 2 positive. You're right. Thank you. Here is up. So like this and up. So we have like this graph. So we have it. So how can you find this integral? So you need to find area, is right? This whole area. This is a whole area, this one. So let me see. You can cut from here. Like this is 0. This is pi over 2. This is pi. So this area is exactly same to this area. You can cut here. This area is same to this area. Cut. This area is same to this area. What's that? This first area is same to original one, this area. From 0 to pi over 2. So how can you do that? You can find only integral from 0 to pi over 2. Only without absolute value sign of x. How many? This area? 1, 2, 3, 4, 5, 6 times 6. This is the whole idea. So like this. The next is integral sine x. Do you know what is integral sine x? Integral sine x is, what is integral sine x? Do you know integral sine? The integral sine is the negative cosine. You plug pi over 2 and 0. We have 6 negative cosine pi over 2 plus cosine of 0. Cosine of pi over 2 is 0. Cosine of 0 is 1. The 6 times 1 is 6. This is final answer for solving this problem. So what's integral cotangent square of x? So we don't have a formula. So what's like integral cotangent? I can use identity. Do you know this one? The 1 plus cotangent square of x is the cosecant square of x. You subtract 1 from both sides. What happens? Cotangent square of x is cosecant square minus 1. You can change it. integral the cosecant square of x minus 1 dx. So what's integral cosecant? Integral cosecant is negative cotangent of x. Integral of 1 is just x plus c. This is answer of D. So like this. The E. So let me see. How can you solve this problem? 이내거 cosine x over sine cube x dx. Do you know? How can you solve this problem? We cannot find exact antiderivative of cosine x over sine cube x. Really difficult. So what's like the best way? We can use U substitution. We can use like U substitution. What is U? You know what is U? So what is U? Sine cube x. So let me see. Only inner function is better. So you can think about it. So you can just choose U equals the sine cube x. Cube x. What's it like du? Du equals sine the cube x prime dx. So we have the du equals, use chain rule, 3 times sine square of x times sine prime is cosine x dx. Here we have only cosine x, we don't have 3 sine square of x. In this case, only use inner function sine. What is u? U equals only inner function sine x is better. Why? What is du? Du equals sine of x prime dx. What's like du? The du is sine prime is cosine x dx. Yes, we have cosine x dx in integrand. This is a good choice. This is like an idea. So we have u equals sine x. The du is sine prime is cosine x dx. You can change it like this one. You can change this one to the like this. 이내거 here. The was it like u? U is sine x. Exactly this one. The cosine x dx is only du. We have it change one. The next, you need to change lower limit, upper limit. You plug this value into here. We have g of pi of 6. You plug pi of 2 into same here, g of pi of 2. So what's that? 이내거 u 1 over u cube is u to the negative 3 du. So what's it like g of pi of 6? Plug pi of 6 into sine function. You calculate sine of pi of 6. Do you know sine of pi of 6? The sine of pi of 6 is, do you remember what's the sine of pi of 6? The sine of pi of 6 is, yes, 1 over 2. You're right. You can plug, this is 1 over 2. What is g of pi of 2? G of pi of 2 is pi of 2 into here, sine pi of 2. What is sine pi of 2? Sine pi of 2 is, yes, 1. So we have it. So next, find antiderivative. 1 over the negative 3 plus 1, u to the negative 3 plus 1 from 1 over 2 to the 1. This is negative 2. 1 over negative 2, u to the negative 2 from 1 over 2 to the 1. So change it to the next one. 2, u to the minus 2 is 1 over u square. This is 1 over 2 to the 1. You can plug upper limit into u, negative 1 over 2 times 1 square minus 1 over 2 times like 1 over 2 square. So what's that? This is negative 1 over 2 minus negative 1 over, so 2 times 1 over 2 square is 2 times 1 over 4. 2 is crossed out. We have 1 over 2. We have 1 over 2. What's that? Minus 1 over 2. Change positive. The 1 over 2 is only 2. So we have 3 over 2. This is answer of this question. This is the idea, like this. The next one, 1 over 2x plus 3 to the 5 dx same. We don't have antiderivative of integrand. You can use U substitution. What's U? Yes, 2x plus 3. Yes, inner function. So we have inner function 2x plus 3. So we have it. The du is 2x plus 3 prime. The 2x prime is 2, 3 prime equal to 0, 2 times du. So we don't have 2 divided by 2 here, is right? Divided by 2. So we have 1 over 2 du equals dx. Next, change. 이거 1 over. The 2x plus 3 is u to the 5 times what's dx? dx is 1 over 2 du. This one. Next, take out 1 over 2. The 1 over u to the 5 is u to the minus 5. Next, you can find antiderivative. You keep 1 over 2. 이내걸 u to the minus 5 is 1 over negative 5 plus 1 u to the negative 5 plus 1 plus c. The minus 1 over a u to the 4 because this is same to what? 1 over minus 4. The 1 over 2 times 1 over minus 4 is negative 1 over 8. u to the minus 5 plus 1 is u to the negative 4. Exactly same to 1 over u to the 4. So we have here. The next, change back. You plug 2x plus 3 into just u. So we have negative 1 over 8 times 2x plus 3 to the 4 plus c. The next, x over 2x plus 3 to the 5. What's the difference? This case is we have only 1. So this is we have x. This is the only difference, but same u substitution. U equals 2x plus 3. This is here, like this, like in the right. So this one, what's the du? du is 2x plus 3 prime is this one, divided by 2. So we have 1 over 2 du equals dx. So how can change? This one is like this. 이내거 was bottom on u to the 5. Was like dx, we have 1 over 2 du. We have one trouble. How can deal with x? We can use this relation. You can solve this equation for x. Subtract 3. So we have the 2x equals u minus 3. You divide by 2. So we have x equals u minus 3 over 2. You plug this value into numerator. So we have u minus 3 over 2. So simplify. This is same to 이내거. Numerator u minus 3 over 2 times the u to the 5 reciprocal 1 over u to the 5 times 1 over 2 du. You can take out coefficient 1 over 2 times 1 over 2, take out 1 over 4. You combine u minus 3 over u to the 5 du. The next, you have to split. U over u to the 5 minus 3 times u to the 5 du. So what's that? Keep 1 over 4. So u is crossed out. Only 4. We have 1 over u to the 4. Negative 3 times 3 over u to the 5 du. You can change it to the negative exponent. We have u to the negative 4 minus 3 times u to the negative 5 du. Here, keep 1 over 4, find antiderivative. Antiderivative u to the minus 4 is exactly 1 over the negative 4 plus 1. U to the negative 4 plus 1. So what's that? This is same to 1 over 4. Oh, the one more, sorry. Keep negative 3. 이네걸 u to the minus 5 is times 1 over negative 5 plus 1 u to the negative 5 plus 1 plus c. And simplify. 1 over 4 times. This one is negative 1 over 3 times u to the negative 3 is 1 over u cubed minus 3 times this is the negative 1 over 4 u to the minus 4. Would you like u to the minus 4? U to the minus 4 is 1 over u to the 4. So we have here, this one is the 1 over u to the 4 plus c. So simplify. The minus 1 over 12 u cubed, negative 1 over 12 u cubed. The negative 3 times negative 1 is positive 3. So this is 4 to the u4. This is not a final. You can plug the 2x plus 3 into u here. So answer is negative 1 over 12 times 2x plus 3 to the power cube plus 3 over 4 times same. u is 2x plus 3. 2x plus 3 to the power 4 plus c. This is final answer. So like this. This one. You got it? This is the whole idea for solving this kind of problems. So like this. The next one. Here, the what's that? The very similar. Was like u. Was u? The u is yes. The square root of x is like u. So this one, take du, the square root of x prime is 1 over 2 times root x dx. So we don't have 2. You can multiply the both sides by 2. So next one, please cross out. 2 du equals 1 over root x dx. Next, change. 이네가 1 over. The cosine square of root x is u. The 1 over root x dx. 1 over root x dx is 2 du. We have 2 du. You can take out 2. 맞아, 1 over cosine square. 1 over cosine square is secant square. This one. So find antiderivative. integral secant square is tangent of u plus c. You change back. So u equals the square root of x into here. The final answer is 2 times tangent of square root of x plus c. We have this answer. The next is this one. So what is u? So what is u? The u is yes. inner function 1 plus tangent x. Yes, inner function 1 plus tan x. What's du? du is 1 plus tangent of x prime. Tangent of x prime is secant square of x. That is one. So you can replace here integral. You plug 0 into here. Tangent of 0 is 0. 1 plus 0 is 1. Change. You plug pi over 4 into x. Tangent of pi over 4 is 1. The 1 plus 1 is 2. The 1 plus tangent x is just u to the 4. The secant square of x dx is here, du. We have simple form. Next, find antiderivative. 1 over 5 u to the 5 from 1 to 2. The key 1 over 5 here, 2 to the 5 minus 1 to 5. We have 1 over 5, the 32 minus 1. So we have 31 over 5. So we have it. This is the whole idea for solving this problem. Like this. So next one, integrals of symmetric functions. So what does it mean? Suppose f is continuous on interval minus a to a. So function f is even function. Was integral from minus a to a f of x dx 2 times integral from 0 to a f of x dx. So if f is odd function, f of minus x equals minus f of x, was like integral from negative a to a f of x dx, so equal to 0. So this is true. But here, function f is even function. This area is this area plus this one. This is always symmetric about y-axis. This area is exactly same to this area. So you can find right hand side times 2. So that's it. This is always true for the even function because even function is symmetric about y-axis. Like other function, the symmetric about the origin. Exactly this area plus this area. We have same area, different sign. It's like negative, this is a positive. So integral from minus a to a, other function dx is always 0. This is always 0. This is like whole idea. So this problem, the answer is 0. Why? Here. This is f of x is integrand. This is f of x is integrand. You can calculate f of minus x. The sine minus x over 1 plus minus x squared. The sine function is odd function. It's always odd function because what's the sine function? Graph is the next one, always symmetric about the origin, like odd function. Sine function, odd function, what does it mean? Sine of minus x is minus sine x. So like this, take out, we have minus f of x. This is what? Odd function. The integral of odd function from negative a is 0. So we have 0. This is the whole idea. The next thing, here, we think about how can you find the area between two curves here. How can you find the area? So first one, you can find intersection point AB. Find the points of intersection. Solve f of x equals g of x for x. X equals AB. Step 2, find area A. Always top on curve minus bottom curve. Integral from A to B, top on curve minus bottom curve dx. This example, find the area of the region enclosed by y equals x cubed and y equals x. So like this. Is right? How can you find? First one, intersection point, you solve. x cubed equals x. Subtract x from both sides. We have x cubed minus x equal to 0. Factor out x, factor more. We have 3 points, minus 1, 0, 1. This is like graph. We have minus 1, 0, 1. We have 3 intersection points. Step 2. How can you find the A? Here. Minus 1 to 1 was a top-on curve. Top-on curve is y equals x cubed is top-on. Minus bottom curve, y equals x. Plus 0 to 1. Top-on curve is change, x minus bottom curve, x cubed dx. Next, find antiderivative. So, integral x cubed is x to the 4 over 4 minus x squared over 2 from minus 1 to 0. Second one is similar. X squared over 2 minus x to the 4 over 4 from 0, 1. So we can plug the 1 and 0. We have this answer. So 1 over 2. The calculation is up to you. So the key part is how can you find intersection point? How can you set up? How can you find antiderivative? The remaining part is just calculation. This is the whole idea. Next one. Consider range S that lies between two curves, x equals f of y and x equals g of y. And between the horizontal lines, y equals to c and y equals to d, where f and g are continuous function. F of y is greater than y equal to g of y for all y in c and d, the interval c and d. So like this. How can you find this area between two curves? This is the idea. Integral from c to d, the f of y, like right boundary, f of y minus left boundary here, g of y dy. This is area, exactly right boundary minus left boundary. So like this. We try to solve one more problem. Find the area enclosed by the line x equals y squared and the parabola. This is like change, sorry. This is parabola here. This is a parabola. This is a line, sorry. Typo. This one. Is right? Was it like x equals y squared? This is the red one. The red one is exactly x equals y squared. The y equals x minus 2 is line. The y-intercept is negative 2, x-intercept is 2. So you need to find intersection point. Here, intersection point first. So how can you solve? You solve just y values. Here, you can find just y values. The y values. So you just only change this one to the add 2 to the both sides. We have x equals y plus 2. You can solve y squared equals y plus 2. You solve y squared equals y plus 2. You subtract y, subtract 2. So we have y squared negative y negative 2 equal to 0. You factor y minus 2 times y plus 1 equal to 0. Was y? Was 2 and the y equals 2 and negative 1 here. 2 and the negative 1. You can find intersection point like this. The next step 2, find area. Was it like area? Integral from lower limit negative 1, upper limit 2. What's that? Right boundary x, the y minus 2. This is y equals x minus 2. You can change it to the x value. Same to what? X equals y plus 2. This is y plus 2. Y plus 2 minus the left boundary is red one, y squared. like this. So we have it. The next, find antiderivative. Y square of 2 plus 2y minus y cube of 3. You plug 2m minus 1 into y value. The calculate answer is 9 over 2. So what's like a key part? The key part is find intersection point, the setup, the right boundary minus left boundary. This is the whole idea for solving this problem. The next thing. So we have disk and washer and cylindrical shell method for finding volume, the volume. So find the volume of a solid obtained by rotating the region bounded by y equals f of x, y equal to g of x, x equals a, x equals b about specified line. So how can you solve this kind of problem? I can show a little bit to you. But here, we have two cases. This one, we have y equals f of x is given, the y equals g of x is given. We have a and b. This region. The what's like the rotating axis? The rotating axis is horizontal line. So we have here, the rotating axis is horizontal line. You can rotate this region about horizontal line, the horizontal rotating axis. So what kind of method do you want to use? In this case, you have to cut this segment. You have to rotate this segment about rotating axis. We have washer. We have like a washer method. You have to rotate horizontal line. You have to use what? Washer or disk method. Washer or disk method. This is idea. So another one. Oh, the depending on the here. This is like a good question. So let me see. The here, the we have only this graph. This one. So you have to rotate this graph about x-axis. What happens? You have to cut this one. This is the center of rotating axis is this one. You have to rotate. What's that? We have disk. But we have gap. We have a gap between rotating axis and solid, this region. We have some gap. In this case, cut this one. You have to rotate. This point has like a big circle. This one has small circle. Exactly washer, depending on we have a gap or not. So we don't have a gap between region and rotating axis. We can use disk method. So we have some gap between region and rotating axis. You have to use washer method. Does it make sense? So what do you think? Okay, good. So this is idea. The another one here, we have same things. This is f of x. This is like g of x. We have same region. You have to rotate this region about vertical line. The vertical line. In this case, we have to use cylindrical shell method. Rotating axis is vertical line. You can use cylindrical shells method. How can you make it? Same. You can cut by using one X. You can make a rectangle and rotate this rectangle about like rotating axis. We have cylindrical shell, is right? So you can rotate this rectangle about rotating axis. We have like a cylindrical shell. This one. You can make a cylindrical shell. So like this. What is average radius? Average radius is from here. This point is this one. This one is a rectangle. This one is exactly rectangle. This is midpoint. Midpoint of a rectangle is like here. The center is rotating axis. So this length is exactly radius. What's the height? The height is the difference between two function values, f of x minus g of x. This is like height, right? I can explain more. Case 1, rotating axis is horizontal line. Use disk or washer method. The cross section is disk AX is pi times radius squared. The cross section is a washer. The AX is the pi times outer radius squared minus inner radius squared. The volume is the integral A to B like AX dx. AX is a disk or washer. For case 2, the rotating axis is vertical line. You have to use method of cylindrical shell. The volume is the integral from A to B, 2 pi times radius times height times dx. So opposite one, f of y, g of y. In this case, opposite. So rotating axis is horizontal. Use cylindrical shell method. Volume is integral c to d 2 pi radius times height. The case 2, the rotating axis is a vertical line. Use disk or washer method. The disk is ay. The pi times radius squared. The washer, the ay is pi times outer radius squared minus inner radius squared. The volume V is integral from C to D ay dy. This is the whole idea. I can show some example here. Find the volume of the solid obtained by rotating the region enclosed by y equals minus x squared plus 4x and y equals x. So how can do that? So graph is like this one. Find the intersection point. The negative x squared plus 4x equal to x. You solve. You can only add x squared from both sides, subtract 4x from both sides. Cancelled. The x squared, x minus 4x is negative 3x. Factor out x. X is 0 and 3. Is like intersection point. So intersect the region by a line passing through x. This is like later. I can just show later. The graph is like this. Here, y equals x squared plus 4x is like this curve. So open down here from 0 to 3. The intersection point is 0 to 3. We have it. This is y equals x. We have this region. So you have to rotate about x-axis. How can you do that? Same. You can make a segment. You can choose x value. You have to cut. The next, you have to rotate. This is segment about rotating axis. What happens? Outer one has big circle. Inner one has small circle. So like this, you can find washer. This is washer. So what's like A of x? Outer radius is from here to here. Exactly here to here. This is outer radius. Exactly function value on the curve minus x squared plus 4x. This is outer radius. What's like inner radius? From here to here. Exactly small one. This is inner radius. The inner radius is the function value under the line y equals x. Here y equals x. So what's that? So pi times the outer radius negative x squared plus 4x squared minus inner radius x squared. So next, take integral. What's like a volume? Volume is integral from 0 to 3. dx integral from 0 to 3 dx. So that's it. You can expand it and solve. This is the whole idea for solving this problem. So like this. This one. Does it make sense? Okay, the next one. Find the volume of a solid obtained by rotating the region enclosed by y equals minus x squared plus 4x, y equals x, same. You can find intersection point exactly same to the previous one. So we have it here. What's like a rotating axis? The vertical line. The rotating axis is vertical line. How can you do that? You choose x. You have to cut. You can make a rectangle. You have to rotate this rectangle about y-axis. What happens? So we have like a cylindrical shell. Cylindrical shell. So you need to find average radius. What's like average radius? So here, you can choose midpoint on the midpoint on the rectangle. You can expand to here, rotating axis. This length is exactly radius, same to here, x value. So this is x. What's the height? Height is difference between function values. So we have this curve y equals minus x squared plus 4x is this value. This one exactly function value on the line like x. So we have negative x squared plus 4x minus x. So we have negative x squared plus 3x. How can you find exact volume? Integral from same 0 to 3, same point. So here 2 pi times radius x times height minus x squared plus 3x dx and solve. Here, so like this, you solve. So that's it. This is the idea by using shell. So we have more problems, the same. So here, what's that? The same things. Only difference is rotating axis, y equals negative 2, exactly horizontal line. You have to use washer or disk method. How can you decide washer and the disk? Same. You can choose x value. You have to cut. We have segment. This segment is, we have a gap between segment and this one. We have a gap. We have a washer. You have to rotate this segment about rotating axis, y equals negative 2. What happens? This segment make washer. So we have big circle and small circle. What is outer radius and what is inner radius? Outer radius is from here, this point till rotating axis. This length is exactly outer radius. What is this length? So this length is function value minus x squared plus 4. And what is this length? This length is always 2. You add 2 lengths. The function value minus x squared plus 4 plus 2. So we have outer radius is negative x squared plus 4x plus 2. This is outer radius. What is inner radius? Inner radius is here, 2 rotating axis. This one. So what's like this value? This value is exactly function value on the line. We have x. So this length is always 2. We have x plus 2. So what is a of x? A of x is here, pi times outer radius negative x squared plus 4x plus 2 squared minus x plus 2 squared. You can take integral from 0 to 3 dx. From 0 to 3 dx. So that's it. This is idea. The radius is always x. You said some the previous example, the rotating about the y-axis, depending on the rotating axis. Cylindrical shell, you're right. The rotating axis is y-axis. Rotating axis is y-axis, yes. Radius is always x. But rotating axis is not y-axis. We have different. I can show. You can show the later. This next problem. So anyway, do some understand this part here? You can do Washer method, this one. Okay, good. So like this. So we have it. The next one here, x equals to -2. So we have it here. Same reason. Rotating axis is x equals to -2. Is right. This is not y-axis, but vertical line. So what's that? Same. You can choose x here. You can make a rectangle. You can make a rectangle. You have to rotate this rectangle about rotating axis. We have cylindrical shell. The cylindrical shell. What's it like a radius? The radius is here. This midpoint, this one is like a midpoint of rectangle. You can expand it to rotating axis. This is a radius. So let me see. What is this one? So this length is always 2 in this case. What is this length? This length is here. Same to x. So we have 2 plus x. This is what? 2 plus x. What's it like height? Height is always the same. Height is always the same by using cylindrical shell. Exactly. Difference between two function values. The top one function is negative x squared plus 4x minus the lower, like the lower one, x. So we have minus x squared plus 3x. What's it like a volume? Volume is always integral from 0 to 3. 2 pi times radius, 2 plus x. So we have the negative x squared plus 3x dx. You got it? It's different, right? The rotating axis is like x equals -2. You have to add 2. Add 2. This is idea. So 2 more. 2 more. So here, this is answer. This one. The next one, y equals to 5. Here, the same. The rotating axis is horizontal line. You have to use Washer method. So what happened? This is segment. Here, we have gap between rotating axis and the segment. We have gap. Here, we have gap. We use Washer method. You have to rotate this one. So what happens? We have Washer. So what is outer radius? What is inner radius? What's outer radius? Important thing is that center of circle is on the rotating axis. So rotating axis to the very farthest one, this one. So this is like longest length, the outer radius. Outer radius is from here to here. So what's that? So what's like this length? This length is always 5, is right? This length is 5 minus, what's this length? This length is x, is right? Here, exactly. The point on the line, like x, what's outer radius? Exactly. The 5 minus x. Here, 5 minus x. The next one. What is inner radius? Inner radius is from center here till this one. This is inner radius. How can you do that? The same. So this whole length is 5. What is this length from here to here? So this one is point on the curve. Is right. This length is point on the curve. The negative x squared plus 4x. So what's that? 5 minus negative x squared plus 4x. Here, this one is inner radius is 5 minus negative x squared plus 4x. So we have 5 plus x squared negative 4x. So what's it like a of x? A of x is pi times same. Outer radius 5 minus x squared minus inner radius 5 minus 4x plus x squared. Squared, you can take integral from 0 to 3 dx. Integral from 0 to 3 dx. So that's it. This is the whole idea for solving this kind of problem. This one. So last one. So like this. Here, rotating axis is vertical line. Here, rotating axis is this one, green on. So what's that? You said this one, cylindrical shell, this problem, or this one? Here? So what kind of cylindrical shell? Like a previous one or this one? Oh, this one. Oh, not x plus 5. So I can show to you. Here, same. You can cut. We have rectangle, same. Next one. Rotate about this one. We have cylindrical shell. This one. So like this. You can find radius. What's the radius? So this point is here. Always expand to this one. What is this length? This length is radius. What's the radius? Here. From here to here. This is 5. What is it? This one? This one is x. Is right? This is x here. What's that? This radius is 5 minus x. Is right? So 5 is like a positive number, always subtract. We have 5 minus x. This is 5 minus x. So here, the height is the difference between two function values, top one minus bottom one. Top one is negative x squared plus 4x negative x. So we have minus x squared plus 3x. What's like a volume? Integral from 0 to 3. We have 2 pi times radius 5 minus x times negative x squared plus 3x dx. This is whole idea for solving this problem. Like this. Okay, so this is all for today's lecture. So do you have any more question? So if you have any question, any concern, just write. It's good? Okay. So thank you for attending the today class. So I hope that you will get some good grades on the next week for the final exam. So thank you. So if you don't have more question, you can leave live session. So thanks.